Not started yet. On join. This is the Raspberry Pi. And this is the Arduino microcontroller, and it's where did you do that online? I have links in this. To program these things, we have to C-based language. It's okay, it's very easy. Not see, I cannot see viewer link on this one. Okay. I think we should start. Okay, let's start. Good morning. IoT, all you heard about this one. This is a new buzz word in the industry. It's a upcoming. Uh, let me share the screen for the list. Uh, you'll find lots of videos in YouTube regarding the IoT and everything, and lots of presentation also are there. But today I am going to discuss on Internet of Thing and our point of view, how developer can engage in this IoT. Because uh, let's second go for second slide. You, my name is Pankaj, and you can join me in Twitter and the blogger also. Trust me, a programmer, I do programming. And uh, this is the agenda for today. Little bit on IoT. What is IoT? How data service is going to help on the IoT? Technology and device involvement. Uh, I have taken specific names, Microsoft and Google's, because they are very giant on data services, that's cloud services. And the devices are Raspberry Pi to Arduino, and then last we will go for a small demo, it's hands-on demo, because we don't have lab here stuff from my home, whatever I got. Means there are lots of sensor and lots of things in my home, but I cannot bring all these things today. Uh, okay. Recently, I attend some IoT camp in the Bangalore, and full hands-on experience. It will take 1 or 2 days experience. I mean, if you able to program and all those things. So I'll try to compress all those things within a 1 hour. So, so Internet of Things, where internet and the things are being connected, need to be connect each other. So if you see, couple of years back, we have the mobile phone which were not smart enough. Like we can call, SMS, that's enough. But nowadays, if you pass 3 or 4 years, the smartphone is evaluating our regular life. It can do anything. The apps are doing everything. Like it can measure your, means how your fitness. It can recognize your face. It can, means anything. The app developer do anything with the mobile phone. Why so? Because mobile itself having lots of sensor, it's can interact with the world, physical world. Like GPS location, it can tell you where you are in on the earth today. What is the coordinate you are staying now? Like temperature sensor can tell you the what is the current temperature now. uh, Proximity sensor, it shows how near you are to the phone. Like if you see, uh, if you when you are talking with the phone, the phone light is switched off. So how it is sensing those things. So devices are there. There's a lot of embedded devices already built up, because industries and all all we have embedded devices, but those are not connected. Those are individually developed for that those purpose only. And so if we can connect those devices, and if devices can talk each other, then it will be smart. And you can think like that when nowadays the devices are coming like wearable device, like wristband, watches. It is also like smart now. So single wearable device, if it can monitor your heartbeat, it can vibrate, it can glow, and it can talk to your medical provider. Suppose if you have a severe problem with heart rate, pulse is very high, and it is predicting that in some few minutes you will have a heart attack, and before that it is calling the ambulance and preparing, means giving that primary diagnosis report to the provider, and they are ready with what to do with you. And that will be the final, means possible option for the IoT, like if in a medical, healthcare, transportation. uh, if you think like transportation, public transportation, and nowadays what happen if crowd is gathering in some point and the service is same, and if surrounding platform is able to identify how many peoples are there, and based on that they are transporting the vehicles there. So it will be the most usable, right? So when device will be smart, life will be easier, and people will be more productive, more uh, can get more benefit from that technology. So this is the basic concept. We have devices, one part. uh, Here we have devices. This is us surrounding us, there are devices. We have internet, we have data services, but they are totally now disconnected. Be- so why we are talking about the internet? Because it is a already well established protocol, already have thousands of device which is running internets. So we don't need to give an effort to establish new protocol, new communication media or something like that. So, and can say uh, data service and knowledge base is the main thing we are looking for from the IoT devices. IoT is very small. Like these devices is it's having 64 kilobyte memory. You cannot store so much data there so that it can analyze, um, means knowledge, or it is predict something data, right? So we need cloud services. So emerging cloud services, how also boosting the IoT platform. So there is a one scope from our side, development side. We already know the cloud services. We can engage our development here. We can utilize our cloud knowledge, cloud programming knowledge, web programming knowledge over here to enable the IoT. And you know, lots of us already we are using the cloud services, like you are using Google Drive or Google Data Services, Google I/O, Microsoft Azure, Amazon AWS, and uh, I don't know. You heard about the machine learning and analytical service from the cloud services. Machine learning, it learn itself. Whatever your data is you're sending, based on that, it learn itself, and then it gives you a prediction. So already the machine because behind the scene, the machine learning having uh, the technology called neural network. That means architecture. So to establish a neural network or depth of neural network, you need lots of computer. So you cannot have in this chip. So you need to go for some data center and data service provider like Google. Already have the analytics, good analytic prediction services. Uh, how many of you are using Google now? Have you used Google now? You talk to phone, it will respond to you directly with the search result, with application invoking all this thing. Similar, Apple have Siri and Microsoft Cortana. So also we have the third party application like that. So this is the intelligence. It is coming from the cloud. It's how you're recognizing your voice and it is interpreting to text and searching. This is very cool stuff. So analytical services, it is needed. AI services like machine learning can give more prediction data. It can predict more. It means you have heartbeat monitoring system, you have face recognition system, you have blood pressure monitoring system surrounding you, and it predicts you have some problem or you are fit today. Or like uh, based on your food habit pattern for last few days, it is suggesting you should have this, should have go to this restaurant. This is very good for you. So this kind of prediction, which will help you your lifestyle also. So the data service is the main portion of the IoT because already industry is building the cloud services, and that is the point over here. Technology, like we cannot, the mobile phone, the phone is become smaller. Now it is coming to wearable device like band, and you know I forget the name. Google is inventing a chip which is based on radar system. The radar, the supersonic radar, which identify the means, flights or whatever. So this is the radar is small chip this size of chip. It identify your hand pattern, like your how your hand is moving, how your finger is moving. Radar can identify those. So this small chip, uh, it can place any part of your. It can be in garments. It can be somewhere. So the smaller device is like better fit for the IoT usability. Like bigger device for the industrial use, but for the human interaction, we need the smaller devices. So there are two part of this technology. Like one is the device, one is the software. We need the device who are on the electronics background, who they can build better than us. Like microcontroller, mini computer, which interact with the world with the affected data and said with sensor. So you know This is one microcomputer, and this is microcontroller, and there is a lot of sensor there. This is one sensor. This is humidity sensor. So with this sensor also being developed for the future use. These are the already what we have. We have at around 500 sensor in the industry right now. So we can use those things to implement. Like I was planning to build one IoT device. This is the humidity sensor. So I will put in a my plant, and whenever the soil is dried up, it should ping me. I am dried up. Give me water. So this is this kind of like you can have fun. So basically, yeah, someone ping me. So device we need to use where we can program microcontroller, microcomputer. Microcontroller have means lesser chances of programming because it has controller level chips and the memory is limited. But microcomputer we have better control. There we can write entire web application. So this is the Arduino board, and this is the Arduino IDE where we can write the program. And this is very simple C-based coding, like setup, loop, end up. Inside the loop, you need to read or means invoke the data for the to activate the controls. So these points are called GPIO, general input output system. So you can plug wire there and connect to the sensor, and it will work out. I'll show you. I don't want to waste time here. Software interface already I told like that it is nothing is standardized till now. Means no one has built concrete platform the IoT devices. Like other industry also we have right now whatever I have the knowledge. I am using Arduino and Raspberry Pi, and that is both are C class language. Means in Raspberry Pi you can write C# also using Mono or uh, Python, Node.js. Those are the good option also. And recently Microsoft is moving to Windows 10. So Windows 10 is a universal platform. So being means declaring the universal platform means it works in everywhere. So they have also one OS version for the IoT devices. There still it is a preview stage. It is not released yet, but IoT devices can run the application you have built in a for the web desktop also. So universal app can run in a IoT devices also. So that is a big leap. As in future, you just run one application, it can run throughout the every devices. We don't need to write application for Windows, phone, tablet, and IoT devices. Single program can run entire. So step to the IoT from the industry point of view. So in recently, if you see, why I'm saying that in web technology, mobile app has the limitation, but the IoT don't have the limitation. It's a big audience out there. So whenever it is a big audience, there will be the big money and big scope for the developer. Millions, billions of dollars are there investing on the IoT setup. Like Cisco recently set up. They invested. They agreed to invest billions of dollars to set up the IoT hub. And here is a Google initiative. Though means I have already said there are no standard platform yet to be yet build it, but they are planning to build. Like Google is creating one OS for the IoT devices. So you know how big it will be. So they are building on lower version of the Android. So they are cutting whatever not needed in the IoT devices and creating one soft OS. Its code name is Brillo. You can search on Google, you will get everything about this one, but you will not get the software till now. It is on preview stage. Windows IoT, Windows 10 IoT Core. So this is from the Microsoft. They already released the preview. So I have this one also. Let me check if I have or not. Yeah, I have inside this one, Windows IoT Core. I'll show you how it looks. It is still in preview stage, so it might not so much interesting for us now. So already I've said that one app can run desktop, laptop, mobile, IoT. So it will be wonderful. The from Microsoft point of view, if you are developing from the Microsoft, we'll get new challenges and new features in the future. Uh, Please hold on. I need a power backup. Raspberry Pi is this is a small ARM based processor device which have 900 megahertz of processing speed, and this version of Raspberry Pi 2 it have 1 GB of RAM inside that, and you know it has everything. It four USB port, one LAN port, one HDMI. This is a display module. Like if you have the LCD display, this is the camera module. If you can attach the camera also. So, and this is the power input. I'll show you how it works. But why Raspberry Pi? There are hundred of devices in market already there. First thing is it has a great community. Means you will have the community support. Suppose you are trying to build something and you are trying to search in a Google, you will not find anything help out there. So it will be pathetic for you. And okay, for the Hangout audience, I have option also. Okay, I'll show you them. So this Raspberry Pi devices have great community support. And second thing, I'll say that it is very cost effective also compared to other device. This piece of device is only cost 2,900 rupees. Say in 2,900 you will get a complete computer. Uh, that's it. So it has also the GPIO. This pin, GPIO pin, it you can connect to the sensor and directly get the sensor value. So what does means you can directly interact with the collect the data, process inside that, because it is a computer. You can run web application over here also. So you can directly create a web application where having switches, and you connect it to the your light bulbs through web application from your mobile you are searching. Just switch on off, it will trigger the switches. So second, this is the Raspberry Pi. Let It's very problematic. The device like Arduino is the first open source hardware. Why open source? You can download their configuration. You can download their configuration. You can build your Arduino because they have given everything openly, the data sheet and everything, how to connect the chip, and you can build your Arduino device. This Arduino device is this is a 180 mega chips. This is the processor. These are the GPIO. GPIO have two type of input output. One is analog, one is digital. You know, analog means it directly get the fraction value. Or digital, it will have one on and off type of value. So based on the analog, you will have the analog sensor or digital sensor also. So you can find what you need in your IoT devices. This is one serial port, USB B type serial. You know, the printer serial USB cable, and this is 12 volt input, so it run on 12 volt. It is very very means energy effective device, means one lithium battery it can run 6 months. So in and there are also so the same thing, Arduino IDE and Arduino itself have bigger community. If you log into arduino.cc, you will get lots of demo projects, sample projects, online projects are there. You will have fun to see those. Means you can see how people are creative with the IoT devices. Uh, like one instance I have found, like in in TV channel, some of in a break, there are a lot of advertisements are going on, right? Commercial. So someone built a device which with IR sensor and that sound sensor. So it check the pattern of the commercial. So whenever it is a very loudly or something, it just mute the TV. So this kind of fun type of application and the IoT applications are there. You can find there also. So there are also other devices like hmm, which having the Wi-Fi capability with microcontroller. Those are not so popular till now, but might be that those will be useful. This was very small. I have don't have right now because I ordered those things. They are not arrived to me till now. Uh, this is the Arduino. See, I already said that these have different version and from the community support also. Like this one is that whatever I have right now, and this is Arduino. This is Nano version 3.0. So this both is same, but the size is small. This is already, it's a kind of credit card size of board, and it is a half of that. So whenever you need smaller things, you can go for Arduino Nano and there are lots of variation on the Arduino also. Some community created one flexible Arduino, it's on Fiverr, so it can bend anytime, anywhere. And so this is the basic cloud what we are looking for now for the IoT devices. One is the data. This is the raw data we'll get from that device sensors, like temperature, humidity, vibration, whatever, proximity, light sensor, how those things. Then it will go to the knowledge level using analytics. It will analyze the data and it will create a knowledge for you. Like it after you we build a community of sensor devices that weather shield, like whether we are implemented thousands of area, then we will get the temperature, humidity, and all those things record. After that it can analyze and give you a report how it is going on those area, the weather is how is going on. Then wisdom, after that it can take decision. Okay, this is the thing you need to give alert to those people, like many uh, like tsunami kind of scenario, earthquake kind of scenario, it can, if it can give a alert to the people at least 1 2 hour before the people can survive more than in this area, right? And another thing is machine learning, which is very effective for the prediction. Like so using the machine learning, it can create the wisdom inside that. So this is the pattern. This is from my side. It is not anyone having right now, or it can have. So so keeping in mind this structure, I'm going to the next slide, so that I can show you my idea on the IoT, how IoT can be effective. So, so this is one. Let me excuse me. Very irritating for me. This is the one concept. IoT device can connect to the cloud individually through hub. Suppose you are thinking about home automation, like your coffee maker can switch it on off automatically, or based on the knowledge what it have. And like your washing machine, your fridge, your TV, all these things can connect each other. But uh, I don't want to expose all this device to directly on the cloud. One channel, one hub, through that it will connect. Like we are connecting to internet through the router, right? The router is the hub here. We are directly not connecting to the internet. So I am not exposed. I am exposed through the hub. So it's a consider 2 point we are considering here. One is security. Like in hub level, we can put one security, basic security, and second is it will be cost effective. Means create enabling each IoT device to having Wi-Fi, it will be very costly. So rather than if we have the IoT devices which have like a wireless module, it's very cheap, like say 50 rupees or something like that. It can connect each other, and wireless module will have 1500 or something like that. So it will cost effective. The one module which device will connect to the hub, and hub will connect to the cloud. So hub will be the media of the IoT communication. And this is the direct module where device is directly connected to the cloud. They are sharing the data to the cloud. We'll have one local monitoring system like your mobile, you can say smartphone, which have the local monitoring system, which also connecting to the device and getting the knowledge based data from the cloud. This is the another model. So today I am going to show you the first model, the hub based model. What I have and what I don't have, I am I will connect with the Arduino with humidity sensor, then a Raspberry Pi as a gateway, and Azure as a data service. These are the things I will use. And before that, I will show you that first after that, sorry, after because this is a kind of configuration related issue. So I will show you this demo before. Uh, then I will show you the IoT core Windows preview. Okay. Uh, let's check the. This is the diagram for this one. This sensor will connect to the Arduino with GPIO. Arduino will connect to the Raspberry Pi with serial USB. I don't have the wireless module right now, so that's why I cannot connect. I mean, it can connect wirelessly right now. And then Raspberry Pi connect to the Azure using the internet. So let's start. That is what I'm saying. This is the hub model I have shown to you. Like my internet, if I means I am. It can be Arduino, Raspberry Pi as your hub, but it can be also your other devices like normal PC or mobile phone can be as work as a hub also. So it can be anything. So let's start this one first. This is the Arduino board. I'm going to connect uh, this one. The cable I'm using just I've tied up because it is very messy here. So I'm connect to okay. First the Arduino test I'm showing. Each Arduino have, if you see there are LED lights are there. You can see, can have and see. That time I just open my Arduino ID. That is the reset button. Means when we want to reset the program. Yeah, microcontroller. Yeah, let's me connect to this one. You can power it with this USB. Also has 12 volt power. You can give it to this port. If you connect, it will just show this one. And pin 13, you will see that number is there. Pin 13, and this side is having the analog key. This one analog. Okay. So what I'm going to do, I'm just first running the first program, the blink test. Oh God. So for Hangouts, I'll show you later the IDE. There is sample basics, the blink. Okay, it will open here. This weird. There's a blink. You see the code is very easy over here. Like first one, do two method. It should be one is setup and one is loop, and this is a 13 pin, which is G pin mode is output, means it will output. It will not get the data from the pin. It will give the output to the pin. And we are doing digital write high. Here high means it will off, and low means it is on. Okay. Then 1000 millisecond delay means 1 second. Then low, then again delay. So it will like clocking. Okay. So compile it. And this program is called Sketch. Means it's called Sketch, uploading Sketch, compiling. It's kind of, it's not calling file. So it's compile. And to upload, you need to check two things. One is the board. You need to select the Arduino specific version, and the comport you need to select proper way. Okay. Then you can do from here upload, control U, or this one also upload. So whenever uploading, it's a TX and RX, it will blink. Then after that, you see the light is blinking. This is the 13 pin. You can see here. So this is working perfectly now. It is the blink test for the Arduino controller. Whomever just bought the controller, then this test should pass the blink test. By default, it is loaded. Means if I now remove this cable and connect to the power, it will work. That this sketch will work. So next, let's build the humidity sensor. Okay. Uh, for Hangout, just I want to share the screen that of that blink window, so you can see. I'm not sure Hangout cannot speak from that side. They can. I cannot see who are joined also. And so for this sketch, I am going to open another sketch which I already written there. I cannot want to waste time here. Yes, again it will open here. So this is a humidity sensor. It includes one library, dht.h. It is means written by someone else. I'm just copying those header file. You will familiar with this code while you are writing the C include hash include, and doing this is a serial begin on 9600 baud. Means this is the port number. It will write to the serial pin. I don't have that wireless module, so I am writing this as a serial pin. This cable will carry the data to the hub through serial port. And now it is delay for 2 seconds, and then it's reading humidity, and it is a float temperature, and this is the Fahrenheit temperature. So this is reading one loop, and after that I am creating one a JSON string, which I will post to the cloud. Okay. So let's build. This is the breadboard. This is the humidity sensor, temperature and humidity sensor. It include both, and it have 3 pin. Uh, it has 3 pin, like one ground, or 5 volt. This is the 5 volt is the maximum capacity of this device on 1 ampere. So why I'm telling this, you can burn those uh, sensor if you correcting the wrong voltages. So this may happen. So I am using this red wire for the volt, black for the ground, and this for the data. So you can see this data. Now I am going to connect. I need to see the pin number what I am using there. Where is my mouse? Pin 2. DST pin 2 I am using. Okay. You can check where I am using pin DST pin 2. This. Okay, DST pin where I am sending this one, DST pin. It's a C type of language having simple object oriented nature. So it is creating the object over here. DST is the target object of DHT. Okay. And it is calling the constructor. So I'm connecting the ground. Sorry, it is not ground. Ground 3.5. It's turned on, right? The LED. And data is on pin 2. And now what I have to do, I have to compile and upload this sketch. Whenever just keep in eye this tool LED, because whenever you are uploading, these two will blink. You see this is uploaded. Okay, it's done. So now you will see this RX will be TX will be the blinking because it is getting data from sensor. So it is the indication that you are getting the data. Okay. So now, how can I check that data is getting or not? This is a serial monitor over there. Okay, every time it's opening here. This is a serial monitor. You see, we declare that 9600 birds here, this one, and we are listening from the same port. Okay, and we are getting data as a JSON format. So this is a 23 degrees Celsius temperature in the room now, and humidity level is 37.00%. So you can increase the humidity level like this one. Increase, right? So it's working, right? Live data you are getting. This is the first step we have done. Like Arduino, we are setting, we set at the sensor, connected the wire, and transporting to the serial port. This is the first setup is done. Second, we need to connect the this one. Okay. So okay, I'm going to power from my laptop only. This is the micro USB. It can works. And what I need to do, I need to remove that this one HDMI from here. This is see if you can see. This is what we are loading in from Raspberry Pi. I am using the Raspbian OS. It is like that. Okay. This is now it is kind of trying to connect to the Wi-Fi, and after it may not connect to the Wi-Fi. I need to run command from the command line. After that, I'll show you the Python code, how it is written, and then that. Then I will just connect the data. I'll show you that data is going and how it is going or not, because I need to show you the that Azure services also. For that, I need to connect the HDMI again. So see, this is a full desktop you are getting. The mouse, keyboard, everything will work. Only I need to connect to the Wi-Fi because I need a internet connectivity. For that, I just want to connect. This is the some command like if up w and means this is a Linux command. It is nothing specific to this device. This is the Linux command. You need to know. I'm trying to connect to the wireless. Once it is connected, I will remove this serial from here. Just removing this one. Connect to the Raspberry Pi. So bound to 192.168.10.124. So anyone can connect from the remote also. SSH putty, there is lots of tools are there. SSH tools. We can connect from that tools also. We don't need to have the means the monitor and keyboard, mouse all the time. You can control from the remote also. Now I am going to show you. This is the project directory of mine. Sudo is some kind of used to be a super user. Okay, and nano is the editor. Or late.input.py is the my file name. So this is the code. You can see there is little bit of code. It will connect to the Azure services and will send the data. So first thing I don't know they can see or not. First thing I am doing that import one. Just try to increase the font 20. They cannot see. Are you able to see? Okay. First, that importing serial and time for the date time, which are not using anymore. Serial for the serial communication. And you see that serial initializing to the SCR variable dev.ttyacm0. Unlike Windows we have COM1, COM2, COM4, COM5. The Linux have this type of name of the COM port. Okay, and the 9600 bus I'm connecting to that port. This is a key name. This I will show you later how this goes, and the key value. These are the keys for required for auth authentication to the Azure service. And the service name, bus name is IoT Pankaj. I'll show you that also. And using that, I'm creating one service bus instance here using a key name and the key value. And sbs.create event hub. It will create an event hub. It is not using actually. I am sending to different event hub test. Okay. So while one serial line dot serial read line. This is reading from the Arduino data, whatever we are sending. Then I'm printing to check what is the serial line it is sending. Then sbs.send event test and serial line dot decode, because this will come as a binary format. You need to decode to the text format to send to the event. Sleep one, it's not misleading information. One means 1 second. Okay. Here it is not millisecond. You need to keep in mind that. In Arduino it is millisecond, here it is in 1 second. So it needs to sync between two devices. So we are done. I cannot share screen because it is in a different devices. I'll share again through a remote terminal. Okay, just hang on for a few seconds. Just let me complete over here. Uh, yeah, let me run this one. I'm connecting to this one. Yes, it will light up the TX. Okay, then I'm just exit this one. The command to run is sudo Python file. Now it is getting. Now it is printing means it is sending to the hub. Okay, this is we are done. So let me share the screen from my computer itself and connect from the remote terminal how it works. Okay. Uh, okay. Share the screen. So it's done. You understood. I need to disconnect the VGA. Okay. I'll show from the terminal now because it's very hard to present from both and don't follow. So I'm trying to connect from remote terminal. Just give me a few minutes. Uh, yes, I have the tool here so that I have to open this one. Let's see. What the IP? You can remember that IP? 192.168.10.124, right? Yeah. The default username is pi. Password is Raspberry. Okay, one second. I need to close that one. Because means at one time both cannot access the same port. Okay. I'm running from the terminal now. This is the same experience you will have. Only okay, it is sharing the screen. It's not showing. Okay. Okay. Now what I'm going to do, I'll run from here this terminal. Okay. This is the same command. Okay. I don't know how to increase the font. uh, this is a terminal window. Oh, don't know. Just see this one. I'll share all the code. You'll able to see the code. First, I need to check. CD IoT projects. CD. Then check what is the file. This. Then I can run the command. So this is I'm keep running this one. Okay. So this is the temperature sensing from the sensor, and it's giving back to the Azure data service. Now I'm going to show you the Azure portal. Okay, how it looks. Hmm. You know, many of us already using Azure. Have you used Azure? No one. You used, right? So this is the basic portal. Here you will get the many of the services they are providing. I am using free trial. So this is what it is called service bus. Okay, and we are going to use, you can use any kind of services. I am going to use kind of MSMQ feature, active MQ MSMQ feature, like queuing up, and it is subscriber provider feature. Someone is subscribing, you are providing that data, and someone can subscribe to that same data, and get the data from the portal. So it's kind of queue feature. So if you go to, okay, so I'm already there. You'll see there is a queue, topics, relays, event hubs. So I'm choosing event hubs because it's keeps the data for few, means for one day only. You know, you cannot, means it's your strategy how you're going to keep the data. So I'm using this one for demo purpose only. And the test, you see, I am using the test hub. Inside the event hub, if you click on the inside the event hub, it'll check the test. Click on the test, it will show you the activities on server side. Okay, let's forget it now because and the key and the service name, IoT Pankaj, I'm using that there. And how you are getting the keys for OAuth authentication? If you configure, you'll get the policy name. This is the root manager shared key I have used there, and this is the primary key I'm using. This one. You have two key, primary and shared key. Secondary key, I mean, for development purpose, use the secondary key. Primary key, suppose you have 10, 20 services which are running on the primary key. You cannot change the primary key, right? Means those devices or those are program need to change. So shared key you can change. Primary key need to be constant on its lifetime. So, and the fact is that that event hub data is refreshing 10 minutes interval. Means whatever is data getting, it is store in a on cloud storage, then it will populate the data. Let's see it screen or not. We'll check later. For this purpose, I have created one project to consume the data. This is providing the data, who is provider, and I'm created one .NET application to consume the data as a consumer. So let's open that one. Okay. You see, this is the program I have written. It is a simple line of code. I am inheriting Microsoft Service Bus Azure data service you need to import from the package manager, and then the event name is same test, and connection string is like you know the connection string you will get from the portal itself. Yeah, this is the connection string you can get from here also. If you click on this one, you'll populate the connection string here. It may be device specific or all or whatever. So this is the connection string, and this is the key I am using, and we are creating one event processing host, which will connect to the event, and then we are registering to the event asynchronously, and and, and then it will write. Okay, so let's run this program. Okay, let's open here. This is the program running console application. See, the data already queued up, it will get at once. Now you will see it will get one by one data. It is posting, it is receiving. So let's me um, run it side by side. One. So this is the Python program we are sending the data. Okay, and this is it is receiving the data. So if I see, see, this is the data it is coming. If you change the data using the same procedure like we did before, it should change little bit. Change, not changing. Yeah, that you will get the data from here also. So this is how the things need to be connected. It is not going for big effort for you, like it is. The only thing is you need to set up the things. The software is ready, the data service is ready, the device is also there. You need to connect those things using whatever you need to do. Like you need to have the power supply, you need to have the input sensors, you need to have the output devices, one microcontroller, one microcomputer, and you are done. And the IDEs, those will come in the way. So where is my slide? So that's it for today. It's a very basic sample, very very basic. Means it can be done within 1 hour. Okay, but I'll show you. Okay, the next thing I forgot that part, that Windows IoT core, right? Okay, I need to connect this one again. Stop presenting. This is this one. I'm going to shut down this one. It has browser and everything. Means you can connect to this one. I don't need this part anymore. So where it is. There's not much thing in Windows IoT till now. Just for preview purpose. It doesn't have anything. Bad luck. Resolution issue. Can you set up the output mode from the remote? Change the ratio, something. It scams very well in my home. It's nothing to do with, because it is a preview. It cannot connect to the wireless. You cannot have those features right now. So maybe not so luck for now. me regarding this one, like anything you want to ask. Yeah, I mean, yeah, that means Azure. I know Azure and Google both had that intelligence services. Like Azure have stream analytics, ML itself, machine learning itself. It has. You see, the part is only you need to think the data, how to send the data to the cloud. After that, everything whatever doing right now, like using the data services, writing code, those are things not needed these devices. Because once you have the data, then you can manipulate the data using analytic services, stream analytics, machine learning. You can write web programming to show this data. You can write mobile programming to show this data. So the part you need to do is need to send this data to services, and somehow you need to send data from services to these devices. Like you need to switch on off. You need to send data from service to the devices, not from here. So this you need to take care of. Other thing, it is a normally you can take, already is there, like machine learning is there from the Azure, and stream analytics are there which can analyze this one. I think there is a one funny application they have created for the demo purpose for Windows Universal App. Old dash how dash old .net. You can open this one. It will upload your picture. It will recognize your face. It will detect the gender from the face and the age. Most of the time it's wrong. One picture it shows me 30 years, one it is 46 years. I don't know how it works, but it's from the machine learning. It learns. The many you use, it will learn from that. Also, you have the Google I/O, Google services. If you have the Gmail account, if you go more and if activate your account for the Google data services, they will also have the means trial features. You can consume the trial. I tried, means I wanted to add one program from the Google services itself, but I didn't get much time for this one. Maybe next time. Huh? This one. For this one, it has 20 GPIO pin. Okay, so 20 data, 20 bit data it can connect. It can be input and output. So 20 devices you can connect. So I'm not sharing anything. So sorry. These are the references I have just used for this project, this demo purpose. Like from uh, this is the Arduino CC, Raspberry Pi, the Microsoft IoT core I have got from here. These are the store I have used to purchase these things: Robomart, Element 14, and uh, InkOcean. It is not received yet. The Google solution for the IoT and the service event hub. If you need to know more event hub, these are the reference I have used. And if you don't have any question, I'm done. I'm packed up. Whenever you're working with the electronic stuff, just be cautious. Thank you. Thank you, everyone.